It just says classification.
Okay, that's cool.
All right, I'm just going to go ahead and start. I know the people from home aren't here yet, but that's okay. They can watch it over again if they want to. So, you three, I'm counting on all of you to answer my questions here. This picture up on the top right, you've got a quiz today over mafic and felsic materials. So, this is a map, and this map is showing ocean crust and continental crust. And just based on whether it's dark or whether it's light, you should know which one's ocean crust and which one's continental crust, because one of those two is made out of mafic rock and one's made out of felsic rock. So that's my first question for you. Sully, the dark stuff, would that be mafic or felsic? You know this. And then you got a 50-50 chance of guessing anyway. Or how about this? I'll give you another choice. The dark stuff, is that like ocean crust or continental crust? Ocean crust. And Tommy, do you know the ocean crust? Is it mafic or felsic? Mafic. Okay, so all the dark stuff, that's ocean crust. And all the light stuff, that's continental crust. Hey RJ, I decided to go ahead and get started early this morning, doing the warm-up. So you can see two continents and then an ocean in between, and all this is broken up into these plates. So we have one, I don't know, it's hard to tell how many plates, but at least one over here, 2, 3, 4, 5. And maybe even more than that. This line, I can't tell if that's really dividing two plates or if it's just one plate that's got some ocean crust and ocean crust and continental crust on it. So one of these letters is not a plate boundary. Which one? Tyler, which one of these is not a plate boundary? A, B, C, D, E, F, or G? Hey, Anna. Which one? Louder. B, yeah. So B isn't a plate boundary. B is what's called, in this case, an ocean hotspot. And that's the only really good hotspot that we have to talk about. So I don't think we're going to really discuss continental hotspots much, but Hawaii is an ocean hotspot. So B is like Hawaii. All right, so we've got number one taken care of. B is not a plate boundary. Name all the plate boundaries in the diagram on the right. So the name, you have to have direction and then name both the plates. So I'll do the first one. A, there are two plates. They're both continent and they're moving apart. So this is continent-continent divergent. I'm going to pick somebody from home this time. RJ, how about C? What would you call this? The name of plate C, the plate boundary C there. What are the two kinds of plates on either side? And what does the motion tell us?
On the motion?
Yeah.
Pretty sure it's. I can't remember, sorry.
Is it convergent, divergent, or transform?
Transform.
Transform. And these two plates, are they ocean plates or continental plates?
Continental.
Yeah, so this would be continent-continent transform. All right. And you can tell, by the way, if you just arrived, these are both light in color, so they're felsic, so they're continental plates. The next one's D. Jace, what would you call D? What kind of plate boundary is that?
Convergent.
And what are the two plates? Is it ocean-continent convergent? Continent-continent convergent. Good. And letter E right here. Harriet. What kind of plate boundary? What?
Divergent.
Divergent, and what kind of plates are they?
Ocean.
Yeah, so ocean, ocean, divergent. And F, Anna, what's F?
Sorry, I was trying to get my phone.
That's okay.
Does it matter like which one you put first? Like,
No, it doesn't matter.
so it's ocean. Is it continent?
Yeah, either ocean continent or continent ocean, it doesn't matter.
Ocean continent convergent.
Convergent, yes. And then the last one's G. Quinn, what would you call G?
Is it ocean,
Yes?
and convergent?
Convergent, yes. All right. So we got that all taken care of. Now subduction zones, there are, if you look at this picture down here, a subduction zone is where one plate goes under another. I tried to look up the word subduct, thinking that it'd be interesting to show you the dictionary definition of the word subduct, and it's not really much of a word. But subduction means one plate going underneath another one. So right here you can see a subduction zone or another subduction zone. So the question is, on this map up here, let's see, which of the convergent plate boundaries will be subduction zones? So we've got, for convergent plate boundaries, they're the ones that are going together. So we have G and F and D. And I'm going to reverse this question. Of those three, D and F and G, one of them is not going to be a subduction zone. So the other two are. In two places where these come together, one plate's going to go beneath the other one. But at one of the three, it's not going to. Does anybody know? Raise a hand if you know which one is not going to be a subduction zone. Liz, which one?
Is it G?
It's not G. G is actually going to be a subduction zone. And so the reason, first of all, the reason you might think G isn't going to be is because on both sides you've got ocean. So if this is ocean crust and this is ocean crust, they're the same density, kind of, so you wouldn't think that one would dive under the other one. But what's going to happen is, just by random chance, one will start to slip under the other one, and also, whichever one's older is going to be colder, and if it's colder, it's more dense, and that's the one that's going to dive. So, and it's also going to have more sediment on it that'll push it down a little bit. So, ocean crust can dive because ocean crust is made out of the same stuff as the mantle. So they're pretty much the same density. But there's a kind of plate that actually can't dive no matter what because it's less dense than the mantle below. So which one's the one that won't subduct, D or F? Anybody have a guess? D. So in the case of D, it's just like what I was just saying. We've got the same kind of plates, except these are made of continental crust. And continental crust is felsic stuff, which is less dense. So even if you took some and you jabbed it down into the mantle, it would just come right back up. It just can't sink. The light stuff, this light stuff can't sink down into the mantle. I just looked at this and suddenly I saw a face. Does anybody see that? There's a mouth here, and these eyebrows, and these are the eyes, and it's kind of like, yeah, it's a little scary looking. Anyway, I got distracted by that. So D is the one. D is the one where when they both hit, neither one can go down into the mantle because the mantle is more dense and they're less dense. So they just kind of smash into one another. And like Tommy was saying, if you go to a science museum, they have these things where you smash rugs together, and when the rugs hit, they go like this, and there's this big teepee space inside. But in reality, it's more like that. I don't know, maybe they just can't get the rugs to do that. They need some kind of better mechanism to maybe two rugs, or something, and some paper in between. Okay, so let's see. I guess that's it for the warm-up. This is kind of a nice diagram. It shows a lot of the things we've been drawing from more than one perspective. We've just been drawing side views of this, but if you, this is more of a perspective drawing. So here you have a plate that's diving, subducting. They don't really show the magma coming from right here like I've been saying it does, but not all artists do it the same. And that makes not just a volcano here, but a volcano all the way up there. And this trench that's right here isn't just right here, it goes all the way along here. And one kind of important thing, ooh, this is just plain wrong. See these arrows? Look at those yellow arrows. Are those correct? No. This is a ocean divergent boundary. See all the red arrows showing the plate movements? So the plate has to be moving to the right. Well, I guess this isn't so bad. Let me, I'm going to try to draw a fixed version of this up on the board. And maybe I can explain what I don't like about it. So freeze that. Show this to, of course my camera's not going to work now.
Mr. Stapleton, your mic is off.
Oh, okay. Testing. All right. Can you hear me now? Thank you. When I unplug that and plug it back in, it turns off. So these two plates are moving apart, and that would be because there's a rising current right here. So I don't really mind that, but these arrows kind of make it look like the current's coming from this way. But if anything, a little bit's going like that, and most of it's going like this. So if you did this, I would just scratch your arrows out and I would redraw it for you. Somewhere down in here, the current's doing this. And I can continue this since we've got the next plate boundary over. This is going to keep going like this and down, and eventually it's going to come back, and this is going to do the same thing. That, and while I'm on a roll here, this like that. And the hot spot's kind of neat. We're going to get to hot spots maybe today, but a hot spot starts from way down deep in the mantle. And nobody knows, at the bottom of the mantle, nobody knows really why it happens, but something just shoots right across these currents. It's called a mantle plume. So this current doesn't stop, and this current doesn't stop, but it's like somebody's sitting on the bottom of a river with a really strong fire hose, shooting the fire hose right up through the current and out the top. And that's what creates hot spots, which...
Mr. Stapleton,
Yeah.
question?
Sure.
I don't understand. Where you've got the volcano with the rising magma,
Yeah.
that current, it looks like it's cooler, it's sinking, and yet it must be super hot underneath.
Right.
Right.
So the question here is, the way I've drawn all this, this must be... This is an especially hot part of the mantle, and we know that because you got this rising current. And this is an especially cool part of the mantle. But the important thing to remember is, either way, this is probably thousands of degrees, and this is thousands of degrees plus some. So this is still really hot. So it's just relatively cool. So when this stuff comes down, it's out here, I'm just going to write cold. So it's next to the ocean water. It comes in here and it warms up, gets hotter, hotter, hotter. And one of the things that allows it to melt is, well, all this stuff is kind of molten anyway. It's warm and molten. This is solid, but as it comes down here, it starts to melt. And remember, this has water in it. I'm just going to write H2O because I don't have much space, because of the water from the ocean surface. And that starts to create bubbles and things which help this stuff rise. So this doesn't have any water in it. It doesn't have the same kind of minerals in it that are coming from down there. So that's one thing that's helping this rise. It's really complicated. I don't pretend to understand all of it. I'm just trying to keep it as simple as we can.
Sorry, I just.
Oh, that's a good question. Does that sort of satisfy you?
Yes,
All right.
thank you.
You're welcome. Well, it's really important to ask those kinds of questions because that's how you understand it better. All right, so now I can thaw my screen. And we're just going to, somebody say something?
I think you might be my.
Oh. And we're going to do a couple other plate boundary drawings and maybe 3 more if it feels right, but otherwise maybe we'll just have an easy day. We've got 2 to do today and then 2 to do tomorrow. 2 to do, sounds like I'm singing. But tomorrow you're going to have more homework, so maybe we'll do 3 today and 1 tomorrow, and then the assignment tomorrow you'll have more time for. So if you have those sheets of paper that I was using yesterday, or if you want to print one out, you can. I think I have a link right here. If you go to class 44, plate boundary drawing template. The only advantage of using that is that it has a little checklist on it that I like to fill out. Yeah, you can use back of yours if you still have it.
Okay.
I'll just give you an extra one. All righty. Anybody seen the Saturday Night Live skit where they teased President-elect Biden for saying malarkey? They were playing Biden bingo, and every time he says malarkey, they get a square. So I feel like you could play Stapleton bingo every time I say alrighty, which I've discovered that I say. All right, so alrighty. One plate boundary that we haven't done yet. I'm going to get it out of my notes just so I can show you what it looks like on the main notes diagram, which hopefully, I think what I do every day is I set them over here. I unplugged it.
Oh, sorry.
No,
It's all right.
here, you can unplug me and plug that back in.
Mess it up.
So we're going to do this one. It's all right. Just sharpening pencils here. So this is going to be Japan. And if you look really closely at my paper, I don't know if you can see that level of detail. Japan is an island, and it's a chain of islands. And on one side there's ocean, and on the other side there's ocean. So the ocean between Asia and Japan is called the Sea of Japan. It's not really, it doesn't have a name that's an ocean. But then out here is the Pacific Ocean. So there are 2 plates that are coming together, and they're both ocean plates, and they're convergent. So Japan is an ocean convergent plate boundary. So the kind of plate here is ocean convergent. And one thing I would hope that you could do on a test in the future is just tell me, well, first of all, draw all the features of an ocean convergent plate boundary, and then just tell me what's there. What kinds of things happen at an ocean convergent plate boundary? That's what we're practicing doing. So, first step, just try to stay ahead of me with this, because I'm doing the same thing every time. This one's actually going to be really similar to one we've done before. So think about what I'm going to do first. What do I draw first? Plates. How many plates? What kind of plates? How thick are they? What color? So 2 plates, light or dark? Dark. And since they're ocean crust is a little thinner. So I don't want to draw a super thick plate. So I'm going to draw 2 plates. And they're dark. And they're convergent, which means they're moving toward one another. And I might as well draw some water up here. Sometimes I don't really know when to add the water, but if it's an ocean, put some water in it. What do I draw next? Does anybody know? This is the 3rd or 4th time I've done one of these. What do I usually draw next? Nobody? All right, the thing I draw next is the mantle. So I need to shade the mantle if it needs to be shaded, and then I need to draw the currents in the mantle. And I could hold off on some of those because I might need to erase them and draw them again if I draw them now. But what color is it? What do the currents look like? Do you know? So the answer for what color it is, it's mafic. It's the dark, dense stuff. So ocean crust is down deep. Mantle is down deeper. The dark stuff is dense, and that's going to be found wherever we're deeper down. The highest stuff is going to be continental crust and seafloor sediment. That's going to be felsic. And then the currents are going to go the same way that the plates go. And I'm not going to draw them in between because I'm going to have some other stuff here. But these 2 plates are going to, or these 2 currents are going to hit one another and go down and then circulate out like this. All right, 2 ocean plates hit. We talked about this earlier. When they hit, you can't really tell from this picture which one's going to dive, but they can dive because this stuff is the solid version of this. If anything, solids are a little bit more dense than liquids because they're cooler, their molecules are slower, so they're more tightly packed. So this actually is dense enough to dive down here. But I don't know which one of these is more dense. And the answer is the older one. We can't tell by looking at it which one's older, but I'm about to give you a clue. Just never done this before, but watch what I'm about to do. Okay. Raise your hand if you know what I just drew. Tommy, what did I just draw?
Floor sediment.
I just drew seafloor sediment. And the seafloor sediment comes from the continents, so I left it light because it's made out of the light felsic stuff. Now, which plate is older? Raise your hand if you can tell me. Tommy again, which plate? The left one or the right one?
Right.
The right one. How do you know, Tommy? How do you know this is older?
It has a thicker layer of
It has a thicker layer of sediment. This would be like looking for the one with the most dust on it. Now, I'm not going to test you over this. I just think it helps you understand the complexity of this. So this is the older one. And if you look at this plate, somewhere way over to the right here, this is where the rocks are born. Somewhere over here, there's this ocean crust factory. And then the crust gets pushed this way as it gets older and older and older. And this plate is the rocks are born over here and they get pushed this way. So that's why the sediment's a little thicker here and it gets thinner that way. And that's why I made it a little thicker here and it gets thinner that way. So when the ocean crust first forms, it forms in a place like this. This is where, at the Mid-Atlantic Ridge, new ocean crust is being created right there. And it's really hot. As it gets older, does it get hotter or does it get colder? As this moves away, here it's hot, here it's molten, here it hardens, and then over millions of years, tens of millions of years, it moves here. Now right there, is this going to be warmer or colder here? Anybody? Anybody want to go out on a limb and guess? It's going to get colder. So as the rock ages and it moves away from where it cooled down and solidified, it gets colder and colder and colder. So putting all this together, the oldest ocean crust with the thickest sediment is the coldest. And if it's the coldest, does that make it dense or not dense? dense. So, which one of these two plates is going to die based on what I've drawn? The left one or the right one? Which one is the old, cold crust? Yep, old, cold, dense crust. The one on the right. So that's the one that's going to dive. So this dives down, and now I need to kind of modify my picture so all this stuff is going down to. So I've got the mafic stuff in the ocean crust, and I've got the felsic sediment on top of it, and then there's this other plate over here that's got mafic and felsic. So now I'm going to draw my arrows because I know where that object is down here. So that's what happens. So this is a subduction zone, and these plates can get subducted because they're at least as dense or more dense than the mantle itself. All right, what happens next? What else should I draw? Anybody? What's going to happen to this crust as it goes down inside the earth where it's really hot? It's going to melt. And when it melts, this sediment has some water trapped in it. It's going to create gas bubbles and things. And all this melting stuff is going to rise up here. So the whole end of this, the dark part, the light part, both kinds of magma are going to rise up. So then they're going to start piling up on the surface. They're just going to come out this little hole, and we're going to have alternating kinds of lava. So this light stuff, that's felsic stuff. That's going to come out sometimes. And this dark stuff, that's going to come out sometimes. So we get alternating layers of light and dark material that are going to pile up and make a steep composite cone volcano. Composite means a combination of multiple things. And this is a combination of different kinds of lava. I've been saying lava sometimes and magma sometimes. This is a really good, if you ever want to be a smarty pants, you can correct somebody when they say magma when they should have said lava. But you need to know the difference. Does anybody know the difference between magma and lava? Okay, here's the difference. One of them is outside of the earth and one of them is inside the earth. What do you call it? What do you call melted rock when it's outside the earth? Lava. When it's inside the earth, it's magma. So this is magma. And then when it comes out here and it either erupts or it flows down the mountain, then it's lava. Magma in the earth, lava outside the earth. There's some other differences too, like the gas bubbles from the water that's in the sediment. Magma has a lot of gases in it. And when that comes out, all the gases escape, so lava doesn't have as much gas in it. All right. I think we've got everything. I just want to talk about, I guess maybe we should go through the checklist. Let's do that. Number one, there are steep composite cone volcanoes. Is this true? Yes. And the reason this can be steep is because it's got what kind of magma in it? Or what kind of lava? Mafic or felsic? Which one makes it steep? You're all going to have a quiz over this Thursday. These people have a quiz over this today. Mafic or felsic? What makes things steep? What's the gooey kind of magma or lava that piles up? Felsic. So all those light layers, those are allowing this to be steep. If it were just the dark layers, this would look like a flat little cow pie. It would all just sort of melt down. Okay, there's an ocean trench here. Do you see an ocean trench? Right there, that's where trenches form. And some of this sediment is going to get filled into the trench, but there'll still be a trench. Relatively violent eruptions of lava can occur. Can we have violent eruptions here? All you need for violent eruptions is you need the light color felsic lava, and we have that, so yes. Relatively gentle eruptions of lava can occur. Can that happen here? Yes, because all we need for that is the dark kind. So this is where the dark stuff is coming from that's melting. This is where the light stuff's coming from. We've got both in here, so we can have both kinds of eruptions. Shallow earthquakes in the crust can happen here. Yes, everywhere. They can happen here in Vermont because we're on a plate and plates can move, and if they move suddenly, we get an earthquake. They happen more where the plates rub against one another, like right here. As this goes down and it rubs right there, or as this magma comes out and it burps out of the volcano, that can cause earthquakes too. How about deep earthquakes? Can we have those? Yes. So anytime you get subduction, this is where the deep earthquakes happen, down here, where this is smashing into the mantle. This is a subduction zone? True or false? True. Subduct means go under. The mantle below this area is relatively cool. Is this a cool part of the mantle? Look at the current. Current is sinking. Does cool stuff rise or sink? Sinks. This is a cool part of the mantle. Relatively cool. It's not, you wouldn't want to be there. You'd burn up, you'd die. But it would be cooler than if you were at a divergent boundary. Is new ocean crust being created? The only new thing being created is this volcano, and it would be a real stretch to call it ocean crust. The mantle below this is relatively hot. Well, no, because we just said it was cool, so let's not do that. There are tall mountains here, but no volcanoes. Does that apply? No, there's a volcano. The tall mountains here are volcanoes. And finally, there are rounded shield volcanoes. Does this look like a rounded volcano? No. We're going to get to those. So that's all we have. That's that. And I think we should do an interesting one. So we should do one that does have a shield volcano. All right, we're going to do the one that I think is the most fun. But before we do that, let me show you some pictures of Japan. Oh, and we need to label this. So this let's call this Mount Fuji. You don't need to remember the name Mount Fuji, but that's one of the volcanoes in Japan. And this would be this could be the Pacific Ocean. And this, I think, is the Sea of Japan. We'll check on it. And can anybody guess what this trench is called? The Japan Trench. I think. Could be wrong. So those are all examples of where we have this sort of thing. And if you want to do this, you could draw this over here. This is Asia. So that would be the continental crust right on the other side of the Sea of Japan. And if you wanted somewhere over here, you could have North America. But I'm not going to put North America there. Oh, here we go. There's Mount Fuji, and that picture was taken in Japan. And then this picture is from above, so you can see the really dark blue right here. What's that? That's the trench. And then these are the islands of Japan. And over here on the left, that's the Sea of Japan. Now there's another famous trench down here. You can see the Japan Trench up toward the top in the Sea of Japan, but the Mariana Trench, that's the deepest part of the ocean. Several expeditions have been made to the deepest part of the ocean. That's deeper than Mount Everest is tall, that trench. And here's an explosion of a volcano on Japan. So the volcanoes can be gentle and they can be explosive. And this was an explosive one. This was Mount Unzen. We're going to watch a video with some French volcanologists, and they actually got killed in this eruption. That cloud covered them up. All right, so let's go on to the next one. What's that? No. And it's actually, one thing you can't tell about that cloud is it's super hot. It would just burn you up too. You wouldn't be able to breathe, and you would burn up. So I think you would just burn first. Yeah. So the next one we're going to do is Hawaii, an ocean hotspot. I wasn't going to do this. This is kind of a fun one. I was going to save it, but we're just going to do it. So looking at this, how many plates are we going to have to draw here? This is different. What? No. Look around Hawaii. Is it ocean? Is it continent? What is it? It's just ocean. A lot of these other places, this is an ocean plate and a continental plate, two ocean plates, continent. This is just an ocean plate. So this plate boundary is going to be an ocean hotspot. And this is all we're going to do today. After we've got this one done, we'll be done. Take a light day. The two that we're going to do tomorrow are pretty easy. So how many plates do I draw? One. And am I going to make it thick or thin? This isn't something you really need to know, but it's kind of good to know. Ocean plates are relatively thin. They're thinner than continental plates. So I'm not going to make this super thin. It really just matters when you're drawing an ocean plate and a continental plate together, because then you need to make the continental plate thicker so it sticks up higher, and it should be above the ocean. It's weird if it's not. All right, so there we go, ocean plate. And I'm going to put the bottom of the mantle down here. And it doesn't really matter to me. We can make this plate move either direction. Does anybody care which way it goes? Anybody want to pick? Okay, so we'll make it move to the right. And I need to shade everything. Oh, let me put some water in the ocean. There's my water. So should I shade any of this, or should I leave it light colored? Ocean hotspot. I hope you all know the answers. This should all be dark. This is ocean crust, which is mafic, and this is the mantle, which is mafic. Now, what are my currents going to look like in the mantle? Can you envision that? What are my arrows going to look like? I need to show currents at the top of the mantle, the bottom of the mantle, and then if there are any rising or sinking currents, I need to show those. So picture the ones at the top, see if they look like this. So all you have to do is just realize that if the plate moves to the right, the current moves to the right. And if it moves to the right at the top of the mantle, what's it going to do at the bottom of the mantle? No, it's going to come back to the left, because this is always cyclic. Whatever happens at the top, the opposite happens at the bottom. So in this example right here, at the top it goes to the right, but eventually that comes down and goes back to the left. In this one, here, the top is going to the left, bottom it's going to the right. Here it's going to the right at the top, left at the bottom. So it's always going to come around somewhere. So the currents at the bottom and the top of the mantle are always opposite one another. All right. Wish I'd left a little more space for this, but I've got to put something in now that you don't know about. So draw a big X down here, and the X marks the hot spot. There is actually one other thing we need to do, but we can do that in just a second. And I love to say this, the hot spot is essentially a spot that's hot. That's about all we know. It's somewhere down deep in the bottom of the mantle. And the mantle is like a river. It's sort of like two rivers. It's a river that goes to our right at the top, but it's a river with another current at the bottom. Has anybody ever been caught by the undertow at the beach? Anybody ever been swimming and had the undertow pull you out? So this is sort of, this bottom part is kind of like the undertow. This is like the top's like the waves coming in, and then the bottom's like the waves sweeping you out. What's that?
When I was in Mexico, I got trapped in a crash down, like big waves.
Just kept smashing it out.
Like drilled into the ground over and
Yeah. So anyway, this current is happening, but the hotspot just shoots a really thin, what's called a mantle plume, straight across this, like that. It's like somebody's got a fire hose that's so powerful they can shoot it right up from the bottom of a river, past all the current, and let the river current keeps flowing, but the plume shoots right across it. Now, before I do anything with the hotspot, there's something that needs to go on top of the ocean crust. What's that? The sediment. And I haven't given myself much space, but where in this picture would my sediment be thicker? On the left side or the right side? Right side, because the crust is moving to the right, and crust always moves from where it's created to where it's getting older. So really it would be good if I made my sediment thin here and then getting a little thicker over this direction. I don't really care how you do it, as long as you put some sediment in there, because there's going to be sediment sitting on the bottom of the ocean floor. All right, from here on, this will make good sense. So this stuff, this is coming from the mantle, and it's coming from deep in the mantle. So is this magma mafic or felsic? Mafic. Anything that comes from down deep is going to be mafic. And this is the only kind of magma we have. Here we had felsic magma and we had mafic magma. So when they piled up, we got a volcano with both. This is going to be a volcano with only mafic magma. This is like really runny chocolate sauce. So what this is going to do when it gets to the top is it's going to create a low rounded volcano like this. And it can actually be a tall volcano, but it's not going to be a steep volcano. And the volcano is going to be made out of the same stuff that came from the bottom of the mantle, so this volcano is going to be dark, mafic. And this would be like Kilauea. I think that's how you spell Kilauea. And Kilauea is in Hawaii. So Kilauea is the big volcano on the big island that people go and they watch eruptions. Now, over time, this volcano right here is not going to stay right here. It's going to move. Where's it going to go? Over here. And the hot spot is going to stay there, but this volcano is going to move. And when the volcano moves away from the hot spot, it's going to cool off, and it's going to get eroded. So is it going to get bigger or smaller? It's going to shrink. So in a few million years, this volcano is going to be here, and it's going to be smaller. And then a few million years later, it's going to be there. And a few million years later, it's going to be there. So what we have in Hawaii is a chain of volcanic islands. None of them are really steep volcanoes. They're these low rounded things. They're called shield volcanoes because they're supposed to be shaped like a shield lying on the ground. They're dark. Has anybody ever been to Hawaii and seen the dark sand beaches? Well, we'll look at that in a second, if I remember. So this is all made of dark mafic rock, and some of the beaches in Hawaii have black sand because they're made of the volcanoes.
I have a question.
Yeah.
When we're like writing this on the test, do you want us to like name the mountains?
I'll show you when we get to that. I think it'll be matching. So what I've done in the past is I'll have let me go to the warm up and I can explain. So it would be like this. So you look at this map, and I would first have you name all these kinds of features. So you'd say A is continent, divergent, plate boundary. And then I would ask you, okay, where in the world do we have a continent, divergent, plate boundary? And we haven't done that one yet, but that would be Africa. Or when we got to B, I would say, what kind of a feature is B? And you would say it's an ocean hotspot. And then the question would say, where in the world is there an ocean hotspot? Or is there one of these, a feature like this? And you would say Hawaii. So you wouldn't have to say Kilauea, you wouldn't have to give me many details. We'll practice before that. So just looking at the map here, really quickly, I'll go through all of them. A is like Africa. Africa is splitting apart. B is like Hawaii. C is like the San Andreas Fault in California. We haven't done that yet. D, this is like the Andes Mountains in South America. No. D is like Mount Everest. D, we have continent-continent convergent. You could either say it's like the Himalayas or like Mount Everest. E, ocean-ocean divergent, that's like the Mid-Atlantic Ridge. F, ocean-continent convergent, that's like South America, the Andes. And then G is like Japan. So there are 1, 2, 3, 4, 5, 6, 7 of these, and there are 7 places, and you kind of have to just remember what's what. Anna, does that answer your question? Okay. So back to, let's fill out the checklist. Steep composite cone volcanoes, yes or no? No. These are rounded shield volcanoes. Do you see any ocean trenches? Nope. No ocean trenches. An ocean trench looks like that. Relatively violent eruptions of lava can occur. So for violent eruptions, we need what kind of lava? Felsic. Is this lava made of felsic stuff? Nope. Relatively gentle eruptions of lava can occur? Yes. This is all the dark, gentle kind. So if you go to Hawaii, you can watch an eruption. And if the lava starts coming for you, you just step out of the way. If you go to Japan, it could just get you, even if you're miles away, it can erupt and kill you in no time. Shallow earthquakes, do we have those? Yes, always. So you can have shallow earthquakes anywhere, but one thing that's going to cause earthquakes here is just this stuff burping its way up out of the earth. That's going to shake these mountains. Volcanoes have earthquakes before they erupt. And while they're erupting, they shake the earth too. But even just this plate moving along, that could cause shallow earthquakes. The only time you get a deep earthquake, though, is when you have something diving like this. This current moving across the mantle, that's not really going to cause much big shaking. Deep earthquakes, no. Subduction zone? Is this a subduction zone? No. Subduction means something goes under something else. The mantle below this area is relatively cool. Is that true of a hot spot? No. Is there new ocean crust being created? So this one, if you have this on a test, I'm not going to give you that option because this stuff is a lot like ocean crust. So I could see somebody thinking, well, sort of, because the ocean crust is made thick and all this new stuff, that's ocean crust like, and it's on top of the ocean crust. So let's just cross that one out. I don't know. That's sort of too questionable to be a good test question. But generally, I would say no. It's not like this. This is some ocean crust, this is ocean crust, and right there, that's where all the baby ocean crust is being born. The mantle below is relatively hot. Yes, hot spot. Tall mountains, but no volcanoes. Is that true? No, there are volcanoes. And finally, there are rounded shield volcanoes. Yes, this is the one where that applies. All right, so that's all we're going to do today. We've got 2 more to do tomorrow. They're not the most interesting, but they'll go pretty fast. We've got continent divergent, and then we've got transform. So for homework, the gold group, you don't really have anything. You've got a quiz on Thursday that these people are going to take now over Mafic and Felsic. But if you want to practice drawing some of these things, that would be good. Just try to do it without my help. That'd be a good thing to do, but you don't have to. Blue people don't have any homework, but they've got a quiz right now. So thank you all for coming. I'll see you tomorrow.
Bye.
Bye.